Hello students, in the previous class we have seen the general characteristics of 17 group element. So today let us discuss about interhalogen compounds. So interhalogen. So inter means what? As we know, according to hydrogen bond, we are consists of two types, that is inter and inter. So inter means two different molecules. So interhalogen compounds is nothing but here we are taking two different halogens. We take both halogens only, but different halogens we are taking. So for example here chlorine, fluorine. Okay, so these are the two different halogens. So those type of things we call it as interhalogen compounds. So by this we can say the definition of these interhalogen compounds is nothing but here the binary diamagnetic compounds. The halogens consist of diamagnetic nature, means which will be having here paired electrons. That one we call it as diamagnetic. Okay, so the binary diamagnetic. The binary diamagnetic is nothing but what here? Two types. Okay, two compounds we are taking. So here the binary diamagnetic compounds made by direct combination of halogen elements among themselves under suitable conditions of temperature and pressure. So we call it as what here? We call it as interhalogen compounds. So what is interhalogen compounds? We can say here. So this is a binary diamagnetic compounds which is made by direct combination of halogen elements among themselves. So at certain temperature, we call it as what here? We call it as interhalogen compounds. Let us see one of the example here. I am taking here Cl2 plus F2 which is having 200 degrees temperature. It is giving 2ClF. Okay, so means what here? This is one of the example. So what I have told you definition here, this is a binary diamagnetic compounds. So this is a binary diamagnetic compound made by direct combination of halogen elements. So these two are the halogen elements by directly combining among themselves at condition of temperature. That one we call it as what here? Interhalogen compound. Okay, so this is nothing but interhalogen compounds. Generally we are having, there are 11 interhalogen compounds we can say. There are 11 interhalogen compounds. So here the general formula will be AXN. Okay, so here A indicates what here? Less electronegative element. So it consists of 11 halogen compounds we will be discussing now. So now the formula will be AXN. A indicates what means here? Less electronegative element. X is nothing but more electronegative element. So here n indicates we are taking odd numbers here 1, 3, 5, 7. Okay. So now it is divided into 4 types, 4 classes. Let us see one by one. So here first one is AX, second one we are having AX3, third one we are having AX5, fifth one we are having AX7, which will be a linear shape, T shape, square pyramidal shape, next one will be a pentagonal bipyramidal. So these are the shapes it is going to have. Okay, so let us see one by one examples here. The first one here, the examples here, it is going to have CLF, BRF, BRCL, IF, ICL, IBR. So for AX3 it is going to have CLF3, BRF3, BRCL3, IF3. So for this we are going to have examples CLF5, BRF5 and IF5. Here we are going to have IF7. So these are the 11 halogens we are having. If you count it, see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total how many we should have here? 11 we are going to have. Okay, so this is nothing but what here? This is nothing but different 4 classes. It is divided. For each examples it is going to have same shape, that is linear. For this all molecules, it is having T shape. For this all molecules it is going to have square pyramidal. For this molecule it is having pentagonal bipyramidal. Okay, up to now we have seen classification and definition. So now let us see about what are the reasons to form interhalogen compounds. Why it is forming interhalogen compounds. So here generally, as we know, the property of electronegativity decreases from top to bottom. So why it is decreasing? Why? Because with increasing size of the atom and atomic number, the electronegativity of halogens decreases from top to bottom. So this is one of the reason we can say. So what is the first reason we can say? The electronegativity. The electronegativity of halogens decreases due to increase in atomic size and atomic number, we can say. Because of this reason the halogens are decreasing. Okay, so here if you take an iodine example, so iodine is having very less electronegativity, so that's why it will show what here? Basic character. Why? Because it will combine with other halogens to form interhalogen compounds. So what we can say here? Iodine will be some basic character. Why? Due to combination of other halogens, we can say. Okay, this is one of the reason. So why it is basic? Why? Because it is having less electronegativity nature. Because of that reason the iodine is having less basic character. So let us see next one. We can see here, due to fluorine is not an central atom. Why it is not an central atom? Because it is having small size, high electronegativity nature and oxidizing property also it is having. Why it is not central atom? We can say due to small size, and strong oxidizing property fluorine will show. Because of this reason what we can say, fluorine is not a central atom, and also it forms halogens like CLF, BRF3, IF7. Okay, so this is one of the reason we can say. So next one we can say, if electronegativity difference between halogens is less, then which type of compounds is going to form here is, if electronegativity difference is less between halogens, is formed by compounds like CLF, means AX and AX3 we can say, okay, BRF, IBR, ClF3. So these type of compounds it is forming. Suppose if electronegativity difference is more, then we are going to get the compounds like so it is getting form AX5 and AX7. So means what here? It is having the examples of BRF5, IF5 and IF7. So these are the examples we are going to have. So then how you will be finding coordination number? If you have been seeing the coordination number is calculated by coordination number of halogen atom is due to radius ratio we can say. So means what here, what we can say, how we are going to calculate coordination number in halogen atom. So here the radius ratio is equals to here radius of larger halogen by radius of smaller halogen. So because of based upon this we are going to calculate the we are going to calculate coordination number. So these are the reasons for the interhalogen compounds, how it is forming. So now generally let us see about the general methods of preparations. So what are the preparations? Let us see one by one. Preparation properties and structures. So coming to here preparation. So if you have been seen here, first preparation direct combination Cl2 plus F2 gives us to 2ClF we can take, Br2 plus 3F2 we can take, 2BrF3, I2 plus Cl2 we can take, 2ICl, okay. So and also we are having different types, Cl2 plus 3F2, it will be giving 3ClF3, I2 plus 3Cl2, it will be giving 2ICl3. So means what direct combinations we are taking. So here Br2 plus 5F2, it will give 2BrF5, okay, and I2 plus 7F2, it will give 2IF7, and also here I2 plus 5F2, it will give 2IF5. So these are the preparations we are having. Direct combination as I have told you. So let us see about properties, what it is going to give. So what is the properties here? So first one we are having, let us see in here, 3BRF. So it is going to give Br2 plus BrF3, okay. So and also here 5IF. 5IF will be giving here 2I2, Br2. Here what it is giving, 3BRF if you are taking Br2 plus BrF3, and 5IF means 2I2 plus IF5, okay. So this BrF3 can also be written as 2BrF3, which will be intermolecular. So BrF2 plus BrF4 minus. So this is the compound it is forming. And also when you react with cesium CSF plus BrF3, it will form cesium BrF4. and antimony F5 plus Br F5, it will give SbBr F8. Okay, so and also if with the CH2 double bond CH2 plus BrCl. So if you break the bond, it is forming CH2Br, CH2Cl. So this is one of the compound it is giving. Okay, so and also like this we are having different types of properties. ICl plus, when you do hydrolysis, it will give OH minus, Cl minus, OA minus. So this is the thing, 2H plus, Cl minus, OA minus, and also BrF6. If you react with BrF6 plus H2O, it is giving 6F minus plus BrO3 minus plus 6H plus. So these are the things, these are the properties it is given. So what we have prepared, that only we have written, means it is a direct combination, it is a reversible reaction. So now let us see each one examples of. So here if you have been taken structures, so let us see first one, structure Cl F3. So the chlorine is having atomic number 17. Okay, so as we have in chlorine atomic number 17, the electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p2x, 3p1y, 3p2y, 3p1z, 3d0. So now you write these orbitals in the ground state we are speaking here. So here 2 electrons, and p orbital consists of how many? 5 electrons, that is 3p5, that is 3p2x, 3p2y, 3p1z. So here d orbitals, how many orbitals we have? 5 orbitals, 1 2 3 4 5, that is 3d is equals to 0. Okay, so in first excited state what happens here? The electron enter into here. So here whenever we write in the first excited state, so then the electronic configuration, how we are going to get? 1 2 3 4. So means what here? 3p4. So in excited state what happening here? The electron is entering into the d orbital, that is 3d1. So if you have been seen here we are having 3 fluorine atoms, means the fluorine atoms is giving electrons to the p orbitals and d orbitals. So by this what we can say here? sp3d. Okay, the hybridization will be what here? sp3d hybridization. So by combining we are going to get sp3d hybridization. So according to Vesper theory and valence bond theory, what we can say, which is consisting of lone pair of electrons. So this here 2 lone pair of electrons, 2 lone pair of electrons, and total 3. So totally how many we are having? 5 sp3 hybrid, means these atoms combining and it is forming a new bond, that is 5 sp3 hybrid orbitals it is going to form. So here by this what we can say means here the ClF3, if you have been seen here, which will be like a trigonal. Sorry, the structure will be like this. First write triangular shape. So here Cl. Okay. So this is F, this is F, this is F. Okay, ClF3. So this chlorine consists of how many lone pair of electrons? 2 lone pair of electrons. So see, if you have been seen here, these are 3 bond pairs we have written. Remaining 2 will be what? Lone pair of electrons. Okay, so it which will be a T shape here. Actually, according to Vesper theory, what we should have to get trigonal bipyramidal shape. But coming to here, which shape we are getting here? T shape we are getting. So these three are equatorial bonds. These two are what here? Axial bonds. Okay. So when you rotate this one, so with angular shape, means when you're rotating this molecule, so automatically what it is getting here when we are rotating this molecule? So it is going to get like this. F, F, F. Okay, so here lone pair of electrons like this it is. So means what? Angular T shape we are going to get here. Okay, so this is of the ClF3 structure. If you have been seen next structure, that is BrF5. The next structure is what here? BrF5. So coming to here, the central atom will be Br, here F5. So here when you take Br atomic number 35. So when you write electronic configuration, what you are getting? 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. Okay, so 10, 10, 20, 26. Still how many required we? 4s2, 4p5. Okay, so by this what we can do? This is the 35 at electronic configuration. So in ground state, how we can write here? 4s2, 2 electrons, 4p5, 5 electrons, that is p2x, p2y, p1z. So now d orbitals is having how many? 4d0. Okay, so now what happens here? Here in ground state, in first excited state, what happens? In first excited state, the electrons is jumping. So in the first excited state, one electron jumps to d orbital. So here 4d1 we are getting, that is 4p4. Okay, in the second excited state, what happens here? In the second excited state, one more electron jumps here. So means what we are getting here? Total 4p3. We are getting here 2 electrons, that is 4d2. So BrF5. So according to VBT what? It donates the electrons to the unpaired electrons. Okay, so these according to Vesper theory, these all will combine and give what here? 5 sp3 d2. Okay, so d2 sp3, so it is giving sp3 d2 structure. So according to Vesper and valence bond theory, it is giving 5 sp3 d2 structure. So coming to here, the structure will be how we are going to get square pyramidal structure. So now if you have been seen, one lone pair, it is having 5 bond pairs. So BrF5. How many lone pair of electrons we are having? One lone pair of electrons. So what is the shape we are having? Geometry square. So this is a square. It is having the shape square pyramidal structure. So this is about BrF5. Like this we can take in this examples ClF5, ICl5, IBr5. So these are the examples we can take. Okay. So next one, let us see the example of IF7. So for this iodine, what is the electronic configuration we are having? What is its atomic number for iodine? So what will be the atomic number? If you have been observed here, the atomic number of iodine will be 53. Okay, so the configuration will be how we are going to get 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p5. Okay, so here if you have been seen 10, 10, 20, 30, 40, 40 plus 7, 47 plus 5, 53. Okay, 47 plus 8, sorry, 47 plus 8, 48 plus 53. So this is the electronic configuration. In ground state, how we are going to get here? 5s2, 2 electrons, 5p5, and 5d0. So this is the thing we are going to get. Now coming to first excited state, what happens? Electron jumps here, 5s2, 2 electrons, 1 electron jumps to what here? D orbital, that is 5d1, 5p4. Next one, in second excited state, what happens? It is having 2 electrons, 5s2, again 1 electron jumps, 5p3, that is 5d2. So again in third excited state, what happens here? In third excited state, s orbital jumps, that is we are getting 5s1, 5p3, and we are having here that is 5d3. So if you have been seen, there is no lone pair of electrons here. All are we are having 7 sp3 d3. Okay, total 7 unpaired electrons. So the fluorine atom is donating electrons to this, which is also known as coordinate covalent bond. So now we are going to get this structure like this, pentagonal shape, that is I, pentagonal bipyramidal shape we are having. So F, 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 F. So 2 pyramidals, no? Here 1 pyramidal we are going to get, here 1 pyramidal we are going to get. So total we are getting pentagonal bipyramidal shape. So this is nothing but what? This is nothing but I have 7 examples. So this is nothing but interhalogen compounds, which is giving binary type of compounds. In the next class we can see the pseudo halogens. Okay, thank you.